Good morning. I hope you have gone through the previous portions where we discussed some of the important reactions of alcohols, aliphatic alcohols. Now we are moving on to some of the reactions of aromatic alcohol, which is often abbreviated as you would know, phenols. So first we will look at the acidic, acidic behavior of phenols. For that, we are treating phenols with the metal. As you would have studied in your lower classes, an acid reacts with a metal to form salt and hydrogen. And in the lower classes, you might be quite familiar with the pop sound experiment, where zinc reacts with an acid, metal reacted with an acid to form zinc sulfate with the evolution of hydrogen, and that hydrogen was trapped in a bubble, and if you light that bubble, a pop sound will be produced. It is called as the pop sound experiment. So it is a universal reaction where any acid would react with metal to form salt and hydrogen. Similarly, phenols also react with sodium to form corresponding uh, salt in the form of sodium phenoxide. Earlier it was for aliphatic alcohols, it was alkoxide, but the O minus aromatic part of phenols is called phenoxide. So in this case, it is sodium phenoxide along with hydrogen gas. Similarly, to illustrate further, phenols react with base, that is, acid react with base to form salt and water, example for neutralization reaction. Here also, phenol reacts with a strong base like sodium hydroxide to form sodium phenoxide and water. But this reaction is not exhibited by aliphatic alcohols. That is an important difference between aromatic alcohols and aliphatic alcohols. Another reaction is esterification reaction, similar to what you have studied in aliphatic alcohols, where phenol reacts with the sodium hydroxide and water to form sodium phenoxide, as mentioned earlier. Then you react with it with the acyl halide. Acyl means CH3CA group. If it is attached to a halogen atom, it is called acyl halides. So acyl halides react with the sodium phenoxide in the presence of a base like NaOH to form an ester, a sweet smelling compound called ester. So it is called as esterification reaction. Here an example is shown where an alcohol reacts with acid to form an ester. So there are two methods of producing an ester in phenols. One is you first react with sodium to make it a sodium salt, and then react with an acyl halide, or you can react with an acid, an aromatic acid or an aliphatic acid to form ester lineages. As you know, ester is a sweet smelling compound, so when its presence or its formation can be easily sensed by the smell that will be formed in the reaction medium. Another example is halogenation reaction. Benzene is rich in electrons, so any electrophile would love to attack it. So in that case, a phenol, it is attacked by electrophiles like halogen, nitro group in the case of nitration, acyl group in the case of Riddlecraft acylation, alkyl group in the case of Riddlecraft alkylation. All these type of reactions come under the cause of electrophilic substitution reaction. So in the first case, we will talk about halogenation, where, as you would know, halogen is being added. So it is called halogenation reaction. The reaction is phenol reacts with the 3 moles of halogen molecule, dihalide molecule, at room temperature to form tri-substituted product. That is one hydrogen. OH, it is a ortho para director. So the ortho positions hydrogens present in the ortho positions and para positions will react with the X molecule, leading to elimination of 3 hydrogen halides, and the other halogen molecule halide will be attached to this eliminated proton's position. That is illustrated by this reaction where phenol reacts with the excess of bromine at room temperature to form 2,4,6-tribromophenol, which appears as a white precipitate along with the elimination of HBr. Here one hydrogen and one Br eliminated as one molecule of HBr, and the adjacent Br molecule gets attached here. Now the second molecule of Br2 attacks this position, and one hydrogen and bromine being eliminated as a second molecule, and that bromine atom will be attached to this position. Similar reaction at this position also to form 2,4,6-5-bromophenol. Similar is the reaction with the chlorine as well. So this is another example. Then nitration. Nitration means addition of NO2. For that you can use a different type of reagents like nitrating mixture, fuming nitric acid, or nitrating mixture, which is a mixture of concentrated SNO3 and concentrated sulfuric acid. You will become more familiar when you do your practicals, where you prepare a nitrating mixture and further react it with the suitable compounds like phenols. So the reaction, the chemistry behind that reaction is phenol react with the 2 moles of nitric acid at low temperatures. We normally do it in ice cold conditions, where the NO2 plus electrophile will be generated, and this NO2 plus E plus, it is an electrophile, so it gets attached to the ortho and para positions. Or in all these cases, the ortho and para positions are being reacted because phenol in phenoxide ion, in phenols, the electron density is more concentrated at the ortho and para positions. So at room temperature, you at less than room temperature, you do this reaction, you will get 2 nitrophenol, either ortho substituted product or para substituted product. Normally, para nitrophenol will be the more stable product due to its less steric hindrance. And if you use excess nitric acid, all the 3 available positions will be blocked to form 2,4,6 trinitrophenol, called as the picric acid. So this is all about the electrophilic substitution reaction or the reactions of phenol. We will look into the another portion in the subsequent portions in the next chapter, in the next session. Thank you.